Hello and welcome. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. We are kicking off a Python Bootcamp. We're going to be looking at how do we go from little to no Python experience up to the intermediate range of Python coding. We're going to be looking at things like variables, if statements, for loops, and how do we use those to actually solve real world problems. So this video is going to focus specifically on variables. They're the building block of everything Python, so we definitely need to cover those. And we're going to be looking at how do we use those and what they actually are. Now, there's going to be times where we have exercises, and it's really up to you if you want to pause the video or not, but you're really going to get the most out of it if you take a second and try to solve these problems on your own. But let's stop talking about it and let's head over to the Jupyter Notebook to begin coding. Okay, Python is up and we are ready to go. Now, I am using Jupyter Notebook to do this, and I'm using that through Anaconda. You can decide to do it this way. You can also use something like Google Colab to do this as well. But what I have up top here is the link to my GitHub page. I'll also put this in the description. But this is where we're going to find all of the templates and all of the solutions that I'm using for this. So if you want to follow along exactly of what I'm doing in this video, go ahead, go over to the GitHub, download this, and follow along on those templates. If not, it's not necessary. We can just code as we go, and you don't have to worry about it. It's just a lot of headers and a lot of the example problems that you'll be able to see on this. Okay, so in this video, again, we're going to be covering variables. We're going to be looking at how do we do some simple math operations with those variables, and then looking at a little more complex variables like lists and dictionaries. So let's just go ahead and get started with the first set of instructions. So first thing is a string, and this is probably the most simple one. It's just a set of characters. It's either a single character or a word or a list of words, a paragraph, whatever it may be. So I have some examples of what those look like. So like hello world, that's probably the most simple and the most basic expression that everyone uses when they start to learn how to code in a new language. But we have other things like a collection of upper, lowercase, symbols, numbers, or just straight up numbers could also be a string. Now, in order to define a string in Python, you can go ahead and just use quotation marks, either a single or a double, and that will give you a string. So if I make a new variable, let's just say I call it x. It doesn't really matter what you call it in this case, but I'm going to say x is equal to, and then again, I'm just going to use simple quotation marks. So I'm going to maybe do the first one, hello world. And this will give me a variable that is a string, and that string stores hello world. Now, if you want to see what is actually in the string, Python has a print function. So if you just type out print with parentheses, and you print that variable, go ahead and run the cell. Now to run the cell, you can either hit the play button up top if you haven't used this before, or you can hit Control Enter. But you can see hello world is what is printed to the screen and what is stored in the variable x. Now you don't need to print, or you don't need to save that into a new variable. You can actually just print it straight to the screen. So if I want to print the second one, if I do another print function, and I put the quotation marks directly in there, and I put the password, and I go ahead and run that. As you can see, it's not stored in a new variable, but it is printed to the screen. And so it really depends what you're trying to do. If you want to save this for future use, you want to use a variable. If not, you can just go ahead and print directly to the screen. Now the thing I want to show with the very last one, I'm going to, again, reassign x in this case, and I'm going to do 1, 2, 3, 4, 5, 6, and 7. I have a double 5 in there. But what I really want to show with this, and if I go ahead and print that to the screen as well, is that while these are numbers, and this could be 1,234,567, this is not what it's stored as within the system. Since we put it in quotation marks, this could be the same thing as hello world for all the computer really cares. It just thinks it's a whole bunch of characters and words. So just be careful of that. And we'll go into how do we swap between multiples, and actually in the next section here, we're going to be talking about what integers are, which is where you could use this if you wanted it to be an actual number. Okay, so that is the very basics of what a string is. We're going to move on to an integer. Now, an integer is really just any whole number, positive or negative or zero. And so some examples here, -2, 0, 2. Very simple. Again, we can assign it to a variable if we want, and then print that variable to the screen. But as you can see, -2 is stored within X and then printed to the screen. And again, just like before, you don't have to save it into a variable. You can print it directly to the screen. Now the difference here is, again, if you want it to be a number, don't put it in quotation marks, because a quotation mark will be a string instead, a word or a character. But you want it to be a number, so go ahead and just print 0 without quotation marks. And again, you can just print 2 to the screen as well. So all of these are examples of integers. Remember, it's a whole number. It's not a decimal place, and it can be negative, positive, or 0. Now, talking about decimal places, we're going to be looking at floats next. Now, floats are those decimal places. So they're any positive number, including 0, but they also have a decimal associated with them. So -2.12, 0.0, 2.1365. Those are all examples of a floating point. So again, just like before, you can assign it to a variable. And again, it will print out. You can print it directly to the screen. Again, don't use quotation marks for this, because this is not a string. This is not a word. It is a actual number value. So go ahead and just print straight the numbers. And you can also print that very last one. However many decimal places that you want. You can also, in the future, we'll go over how do you round them. So maybe you only want to show 2 at a time or whatever. But that's a future episode, so we will stop there. Now, I am moving fairly fast through these. If you happen to be lost in this, don't really worry about it. I need to get through this this very basic stuff. But if you're still lost at the end of this, we're really going to be using these all the time. So you're going to have plenty of practice using these, and it's really going to come naturally. So you don't really need to have a super full understanding of what these are quite yet. The last one I will show you is a bool. Now, it's kind of a weird word if you've never heard of this before, if you've never had experience with programming languages, but a bool is basically just a true or false value. And it's literally what it is, true or false. Within Python, true or false are capital, so make sure that whenever you're assigning a value of true, you are using a capital T, or false, capital F. If you don't, and you put it in quotes, let's say, it will be a string. So it's not the same for other programming languages. If you want to start looking at other programming languages, some use a lowercase t or lowercase f, but in Python, it needs to be a capital T. But a bool, again, is just a true or false value. So true, false. It could also use some sort of logic to say, okay, if there is a number, then it's going to be true. But if it's 0, then it's going to be false. So 1 or 0, or 2 or 0, either one, or multiple values. If it is a number non-zero, it will be true. If it is 0, it will be false. Other things are if a string actually contains characters or contains words within it, then it will be true. If it's just an empty string, so literally nothing is inside of it, it will be false. So just ways of saying if something is true or false. So I can just print true to the screen, and you can see it's true. Now, you can obviously also tell that true has been highlighted in green to show you that this is a bool value. If I were to lowercase t, you can see it is black, which means in this case it will give us an error, but you can make this a string as well. And the other thing I can do is I can just print false, false as well. Now I'm going to show you how to cast something, and casting just means how do you take one variable type and turn it into another. And so, like I said here with these last 4, I'm taking, in this case, an integer of 1, and I want to turn it into a bool. And so in order to do that, I am going to make a new variable called x again, but I'm going to call bool. And then bool is going to take something within its parentheses. So in this case, I'm going to feed it that integer. So that integer is 1. Okay, and so what this is doing is it's turning the integer value of 1 into a bool. That's what this outside 1 is for. So now if I print this to the screen, you can see instead of printing 1, like we passed in, it's printing true because it's now converted. If I do the same thing, actually I'm just going to copy this and come down below it and paste. Now if I do the same thing and replace it with 0, let me scroll down a little bit. You can see that 0 is the equivalent of false for a bool. And if I take this again and just keep copying it down, I'm also going to show you how to do this with strings. So if I pass in hello world, go ahead and print that, you can see it is true. And if I go ahead and do one more, I'm going to do an empty string. Don't put a space in between these quotation marks, just leave it as 2 quotation marks, and I print this to the screen, you can see that it's false. So it's different ways of representing true or false values based on whatever you're passing it. Now this is a perfect segue into, okay, not only can you convert things into bools, but you can convert it into any of the other ones that we've talked about before, integers, floating points, strings. So let's look at how do we do that. In these examples here, I have I'm starting out with, again, it's in quotation marks, so that this means this is a string. It is not an integer because it has quotation marks around it. But I'm going to take this string, I'm going to convert it into an integer. This is what this int is for. So now after we execute this, it will be an integer of 1234. Then we're going to convert that integer into a floating point. That floating point is going to be 1234.0. And then we're going to convert it back to a string. And so let's see what happens when we do this. So I'm going to take a variable called x. I'm going to assign it to 1234. Remember to put those quotation marks for a string. But now we want to convert it into an integer. So actually, let me first print to the screen what x is. Now, this doesn't really tell us much because a string of 1234 and an integer of 1234 will print the same. So within this print function, if you put a comma, you can actually print multiple things to the screen. So I'm going to do a comma. And now I really want to know what kind of variable x is, what type of variable. And Python has a built-in function called type. So go ahead and put type. And type is going to take parentheses, and you're going to pass it in some variable. So if I pass in x, if I go ahead and print this to the screen, you can see it prints out what x is, but it also prints out that x is a string, this class string right here, str is string. Okay, so we can see that we have a variable of 1234, that's a string, but now we want to convert it into an integer. So if I say x is equal to int is integer, x is equal to the int of x, and now I'm going to use the same thing here where I'm printing x, but I'm also printing the type of x. Now when I print that, you can see it's the same thing that printed out for the values, but we can see that it's really an integer this time instead of a string. I'm just going to keep doing this, so I'm going to say x is equal to a float now. This is going to convert the integer into a float. And we could have also just gone directly from the string to a float as well, since it is a number. But in this case, we're just going to go straight down the line. And then we're going to go ahead, print it to the screen. Now you can see, since we converted it to a float, it did add that decimal place of 0.0 to the end of it, and it has converted it to a float. And the last thing I'm going to do is I'm going to convert it back into a string. So I'm going to say x is equal to str. str is string. And I'm going to print that to the screen. Now you're going to notice something different here. Originally we had 1234 as our string, but after we've converted it to a float and added that decimal place, now when we convert it back to a string, it's going to keep that decimal place. So now what this really looks like is if I make a new variable, it's going to look like 1234.0 in quotes, instead of the original up here without this 0.0. So just be careful of that as well. That will happen. If you wanted to get rid of it, you can also just convert the float back into an integer. So you can use a lot of combination of these as you're trying to figure out what you want to do. But again, these are the very basics, and don't worry if you're super lost. Again, you're going to be using these a lot. It's going to kind of come as second nature when you're using these. So don't worry too much. You'll definitely get the hang of it as we go on. Okay, now that we've talked about just simple variables and simple print functions, let's go ahead and look at some math operations. So this really gets Python to the point of maybe your simple calculator, right? 1 plus 2, 1.1 plus 2.2. We're going to look at addition right now, right? So it's very easy, right? So x is equal to 1 plus 2. Okay, this is going to solve the right-hand side first. It's going to say 1 plus 2 is equal to 3. We're going to save 3 as x. So if I print x to the screen, I am going to be printing 3. Now, I don't have to do it like that. Again, like we were doing before, I can print, maybe I want to do the second one. I want to print 1.1 plus 2.2. This is going to solve the whatever's in the parentheses first, and then it's going to print that to the screen. So we're not saving it to a variable anymore, but we are printing the result to the screen. Now you can see we have all of these values in a 3 at the very end, when this really should just be 3.3. That's just rounding within Python. When you start actually adding this and doing more complex operations, those kind of get dropped off, so you don't really need to worry about it. You could also round it if you wanted to, but we'll get into that later. Now in this first case, we were adding an integer with an integer. The second case, we were adding a floating point with a floating point. But with numbers, you can mix the two. So you can add an integer to a floating point. So if I make another x, I'm going to say 1, which is an integer, plus 2.2, which is a floating point. And now if I print that to the screen, you can see I now have 3.2. Now it's going to convert to a float always. If a float is within the equation that you're trying to do, so in this case, if there is a float, it's going to convert to a float. Now it will keep an integer if you have two integers, as you can see in this first one. So that's also something to be mindful of. But not only can you do that with numbers, you can actually combine strings in this method. So if I have a variable and I have the first value be hello, and I'm going to add a second value called world, and make sure these are in quotes. So we're adding two strings together. What happens when I do this is I will have a combination of the two. Now, if I wanted to add maybe a third value into here, I'm just going to add a blank space. Now this one, make sure you do put the space in, because I want to put a space in between the two words. So now I'm adding three values together, and I print that to the screen. Now I have hello world with a space in between. One thing to be mindful of, while you can add integers, integers and floating points together, you cannot add numbers and strings together. So if I try to say x equals hello plus 1, and I print that to the screen, I'm going to get an error. And here we go. Can only concatenate string, not an integer. So it's saying you cannot add an integer to a string. You cannot add a floating point to a string. If I can just do 1.0, it's also not going to let me do that. So you need to be careful of what type you're adding together. What I did here, I added the pound symbol or hashtag. It depends on what you want to call it. This is going to give you a comment in Python. So a comment is going to let you type something in here, but it's not going to run this code. Anywhere it sees the pound sign, it's going to ignore that line. So it's not going to run it to the screen. As you can see, we don't have an error anymore because it's not trying to run these two lines. Okay, fairly simple. And again, we can repeat all of this with subtraction. So if I'm just going to copy everything I had up top. I'm going to bring it down to the subtraction section, but I'm going to change all of these to be subtraction. And the second case, I'm going to remove this space. And I'm going to remove the last one. Okay, so we're going to go one by one through what I did here. So first one, I have 1 minus 2. 1 minus 2 obviously will give us -1, and that will print to the screen. Second one, I have two floats, so 1.1 minus 2.2, it will give us a negative number. The third one, I have an integer minus a float. Again, you can combine two number values, and this will return a float. The last thing I have is a string minus a string, so hello minus world. And this is another one that will not work, along with... obviously, if I cross types here, so if I subtract a number from a string, or if I subtract a string from a number, it's going to give us an error. But I also cannot subtract words from another word. So even if I wanted to subtract maybe the H value from hello, this is not going to work for me. I cannot subtract strings. So if I run this, you can see the first three executed the way we wanted it to, but the last one, I cannot subtract a string and a string. Again, to comment, you can use the pound sign. It does not need to be followed by a space. I just do it to make it look a little cleaner. You can also add as many pound signs as you want. So maybe you want all your comments to have 7 pound signs or 8 pound signs. It doesn't really matter. But again, you can run that, and now we don't have the error. Moving on a little faster, multiplication, same thing. So if I go ahead, I'm just going to grab the top 3, and I'm going to bring them down here. Multiplication is just the star symbol. And so you can replace all of those with the star symbol and go ahead and run that. And as you can see, we can have integers and integers, floating points and floating points, integers and floating points. Again, numbers are numbers, and so they will all do multiplication to the screen. Now, one other thing that you can do, you can use strings and multiplication on this if you're using a integer value. So if I have hello, I'm going to multiply that by 3. What this is going to do is it's going to print hello 3 times. So if I print X, it's going to give me a string with hello 3 times. Or if I change this to 5, it's going to give me 5 times. So that's also something to be mindful of, especially if you want to print like multiple spaces to a screen, but you don't want to count out 15 spaces. You can just do a space times 15 and it'll give you 15 spaces. So that's something that could be useful in the future. Again, moving fairly quickly, I'm going to, again, paste what I did, but I'm going to change everything into a division sign. And go ahead and print that to the screen. You can see we get all of our values. Now, if your result of an integer divided by an integer is a decimal place, so a floating point, it will give you a floating point as an answer. Now, if you had 2 divided by 1, it will also give you a floating point. So again, the result of a division will be a floating point, regardless of if it could be an integer. If you wanted to, again, if you wanted to make the result an integer at the end, you could convert it to an int like we had before, and now our result is back to being an integer. Okay, the last thing I wanted to show was if I have hello, I cannot divide by 3. So while you can multiply by an integer, a string by an integer, you cannot divide by an integer. So again, something to be careful of, and make sure you are aware of what types can go with each other. Okay, exponents, getting a little harder here. So again, pasting here. Now, exponents are represented by a double star symbol. It's not the caret like you may have used in other notations. It's actually 2 star symbols, and that will give you an exponent. So if I go ahead, replace all those, you can see an exponent will actually give you an integer if your result is integer-like. So if you don't have any decimal places after it. Sorry, that is only when both values are integers. If you do have an integer to the power of a floating point or vice versa, then you will get a floating point at the end. Again, if a floating point is part of the equation, it will be a floating point at the end. And again, wanted to show you cannot do this with strings. So I cannot say hello to the power of 3. It will not give me 9 or however many hellos. It will just give me an error that I cannot do this with a string and with an integer. Okay. Now the last simple equation I'm going to show you is actually 2 parts. So base and modulo. These may be new words for you. Base could also be floor. That's another way of representing it. But basically when you have, if I have 10, I'm going to print to the screen 10 divided by 3. And I'm just going to put some spaces to make it a little easier to see. Okay, 10 divided by 3 is really 3 1/3. If I want to only show the whole number part. So in this case, 3 1/3, the whole number will be 3. I can use a double division sign. So I can say 10 divided by 3. And this will only return the left-hand side of the decimal, the whole number part of it. On the other hand, if I want to grab the right-hand side, and this will be, it won't be 0.333, it will actually be whatever the fraction is. So if I print 10 with the percent sign 3, I'm going to get 1. And the reason I'm going to get 1 is because, again, 10 divided by 3 is 3 1/3. So it's going to take the top part, or the numerator of the fraction. And it's going to return only the 1 back to me. This is going to be super useful when you're looking at things like, how do I know if a value is even or odd? So for instance, if I want to know if the value, let's just make some super large value, and I'm saying this value right here, if I want to know if it's an even or odd number, I can actually just modulo 2, so percent sign 2, and it's going to give me a 0. And this 0 means that it is divisible by 2. There is no remainder, which means it is an even number. That's one way to tell if this number is even or odd. If I change this to an odd number, so if I end it with a 1 maybe, it's going to give you a remainder of 1, which means this number is an odd number. Just something cool that you can do with that. You might use it for other things as well. But that's it for the basic math operations. What I'm going to show next is you can do this when you have multiple values storing. So if I have a is equal to 2 and I have b is equal to 1.1, not only can you do a is equal to 2 plus 1.1, you can actually say another one. So maybe I want to save this as c. C is equal to a plus b. Now if I print this to the screen, you can see that the result of c is 3.1, which is really 2 plus 1.1. Just ways of storing values and then using them later so you don't have to type them out, and you can have them be reused throughout the whatever equation you're trying to do. So to end this section, I'm going to do an exercise. I mentioned before that we're going to have exercises throughout this, and it's really going to benefit you if you go ahead and take the time, pause the video, and try to solve this yourself before you watch me do it. Try to, take 5 minutes at most, maybe. Try to work through the solution, see what you come up with, and compare it to what I get. So go ahead, pause the video right now, and we will go ahead and get started. Okay, so in order to start, I'm going to define all 4 of these variables right here. And so I'm going to have a is equal to 2, b is equal to 5, c is equal to 10, d is equal to 1. And what we're really trying to do is we're trying to solve this equation right here. So we want to solve this equation using Python, using the variables that I just defined. And in this case, I'm just going to have the output saved as solution. Again, what you save it as doesn't really matter. You don't want to overlap with, for instance, I don't want to save this as print because print is a keyword, and a keyword means that it already has something assigned to it. So like print is going to print something to the screen. If I reassign it to a value, it's going to mess with a lot of things. So a rule of thumb is if it shows up as green, don't save that as your variable name. So I'm just going to call it solution. My solution is going to be equal to this equation. Now, if you remember back to your math days, maybe in middle school, you do need to be careful of parentheses and where you're putting them. So for instance, I need to put parentheses for the numerator. So I'm going to have a plus b. Make sure you end that parenthesis as well because we want the entire top to be divided by the entire bottom. So again, another set of parentheses. And under here, I'm going to have c minus d. I'm going to subtract this entire thing by a to the power of b. Now remember, a to the power of b, or a exponent b, is a double star symbol. So a power of b plus c power of d. Now I'm putting spaces in between each of these just to make it a little easier to read for you. You do not need to do it this way. You do not need to add spaces. Don't worry about that. You can remove every space if you wanted to. You can have multiple spaces if you wanted to. Really up to you. But what I'm going to do is I'm just going to print this to the screen. And here's our result, negative 41.22222. Now again, be careful of where you're putting your parentheses and your order of operations. So for instance, I didn't put a parenthesis around the entire left-hand side and the entire right-hand side because based on the order of operations, parentheses are going to execute first, multiplication and division next, or sorry, exponents next, multiplication and division after that, and then addition and subtraction. So it's going to put it in the right order. You can add more parentheses if you wanted to, but I just didn't want to clutter everything up. So that's just very simple ways of using these variables and using simple math operations. Now we're going to move past just what Python can do as a simple calculator. Now we're going to get into some more complex things like lists. As you can see, list right here. Here's some examples of them. They use the square bracket, but what it does is it allows you to store multiple values within one single value. So I have this list of, in the first case, a whole bunch of integers, or the second case, a whole bunch of strings or characters. And in the last one, I have a combination of strings, integers, bools, floating points. So they can all be stored as values. If I have x, again, it's using square brackets. Make sure you don't use parentheses here. But I'm going to have x be 1, 2, 3, 4, and 5. I'm adding spaces just for readability. You do not need to add spaces. If I print x to the screen, you can see I now have a list of all of these values. If I come down here, and I'm going to do the same thing, but now I'm going to do A, B, C, D, and E. And I need to print that to the screen, and you can see now we have these characters or these strings stored. Now, one thing you may have noticed is, I don't know if I've done this before, but you can alternate between a double quotation mark and a single quotation mark. They both will give you strings in this case. So it doesn't matter. You're probably going to see me go back and forth. I like to use the single one a lot just because it's easier and I don't have to hit the shift key. But Python does let you switch between the two, so it doesn't matter. Just be careful of that as well, especially when you're trying to print something with an apostrophe in it, maybe. You need to be careful which one you're using, or else it may end your string before you wanted to. Okay, and the last thing I'll show is a mixture of multiples. So if I have A, which is a string, 2, which is an integer, true, which is a bool, and 3.9, which is a floating point, and I print that to the screen, it's going to all be stored within this list. So it does not matter what you put inside of it as far as variable types, it's going to all be stored within the list. Okay, so that's cool. It stores multiple values, but what we really want to do is we want to extract those values from the list. So if I have a list, I'm just going to call it my list. My list is going to be equal to A, B, C, and D. So I have this list of 4 strings, 4 characters. I want to be able to grab one string at a time. So if I print the list, you can see all 4 printed to the screen, but maybe I only want to print the first one. This is very important in Python and when lists. The first element in the list is going to be element 0. It's going to be index 0. And let me show you what I mean by that. If I want to grab the A value, I'm going to print my list. I'm going to use a square bracket, 0, and I'm going to print that. What this is going to do is it's going to take the list. It's going to take the 0th index, which is the first value. Very important, and you're probably going to mess this up quite a bit because I still mess this up. It's something that you may not be thinking. You want to just grab the first one, so you grab or you put in number 1, but it starts at 0. Make sure you are paying attention to that. What this also means is that it will end at the length of the list minus 1. So this value, D, will be the 3rd index, not the 4th. Even though there's 4 elements in the list, it will be 3. Okay, I think I hit on that enough. But as you can see, if I print with a square bracket 0, it's going to give me the first value. If I repeat this, and I change this to a 1, it's going to give me the second value, which is B. And it's going to print that to the screen. Other things I can do, actually, before that, let me, again, 3 is going to give me the very last one. If I also want to get the last one, but I don't know the length of the list, I could also say I want -1. It's going to go 1 from the back, and it's going to print that to the screen. If I want 2 from the end, I can go -2, and it's going to print 2 from the end, which is C. Now, one more thing to show. If I accidentally try to grab 4, and remember, 4 is going to be out here. It's not even part of the list because there are only 3. It only goes up to the 3rd index, not the 4th. So if I try to print this, it will give me an error and say it's out of range. So again, be careful. You're going to run into this error a lot, especially when you're starting out. So just understand that it starts at 0 and ends at 1 minus the length of the list. So time for another exercise. And this is really going to be hitting on how do we index lists. And it's going to be super important, and you're going to be using this quite a lot. So it's very important that you start to get this down. So what I have here is I have a list of characters. And these characters are jumbled, but I really want you to print to the screen using indexing hello world. And you can print one on top of each other. It doesn't matter the format. I just want you to print by order of character hello world. So go ahead, take a second, pause the video, and try to use indexing to print hello world to the screen. Okay, so we are going to go ahead and do this. We're going to be using print statements, and we're going to be printing letters. Now, in order to grab a specific letter, you need to use a square bracket. And this is what the format's going to look like. We're just going to replace in here the number every single time we do it. So I'm going to actually just copy this for future use so I don't have to keep typing it. But what we're going to do is we need to grab the H. Now, a quick way to do this is you just start with 0. So 0, 1, 2, 3, 4, 5, 6. This is 6. If you wanted to get fancy, you can also say it is -2 because it's 2 from the end. But I'm going to start from the left-hand side just to really reiterate that it starts at 0. So that gives us our H. 0, 1, 2, 3, 4. E is 4 away. L is the first index. Again, we need another L, which is the first index. We need the 0th index, which is the O. We need the very last one, which is 0, 1, 2, 3, 4, 5, 6, 7. The W is 2. The O again is 0. The R is 3. The L is 1. And the D is 0, 1, 2, 3, 4, and 5. Let me just make sure that I did this right. But this is basically what you're looking at is how do we index from the very left and just keep printing out all of the letters so they spell hello world. If I go ahead and print this, you can see we did print hello world to the screen. If you didn't get that, or if you're still confused on this, try to make other words, or try to really do this without looking at this at my solution here, and try to figure out how you would actually do this. Because again, this one is super important. Just because you will start indexing lists a lot, and it's very important that you really learn that it starts at 0 and ends at the list -1. But again, if you aren't still quite getting it, don't worry. We will be hitting on a ton of exercises and a ton of practice problems that will really reiterate this for you. Okay. You can also start, not only can you define a list of a whole bunch of values, but you can actually add more values to that list. So if I have my list, oops, and I accidentally closed my browser here. But if I have my list, which is equal to 0, 1, and 2, maybe I want to add more values to that. In order to add more values, say if I want to add a 3 to the end of this list, I need to use the append function. So my list dot append 3. If I go ahead, let me print the original list. And now let me print the new list. You can see that 3 has been added to the list. If I wanted to add another one, I could add a 4. And now 4 is printed to the screen. So that's a way you can add to the end of the list. Now you can do the opposite. You can remove from the list. So now if I have my list 0, 1, 2, 3, and 4, I'm going to print my list. Print it to the screen. You can see I have all those values. Now if I pop the list, so not append but pop, so my list dot pop, and I print the list, you can see it took the last value away from it. But not only that, you could also pop at an index. So if I say my list dot pop 1, and I print my list, this is going to print index 1. If you remember indexing from the last assignment, index 1 is going to be starting with 0. So 0, 1. So it will pop the 1 from this list. You can see it did. And it started with this one up here. So popping the first index. You can change whatever index it is, but it will pop whatever the index value is. Okay. Time for another exercise. Again, with indexing, appending, and popping. So we have this original list, which is right here. So message. Okay, so this list says, programming is extremely hard. We want to change the list to say, programming is super easy. So how do we use appends and pops in order to make this say what we want it to? So go ahead, take a second, try to solve this. Take 5 minutes if you need to, and then come back and see how we're able to do this. Okay. Now, in order to do this, we're going to reassign message. So we're going to say message, but we're going to pop the last value. And actually, we're going to pop 2 values because we need to change the last 2 values. So we're going to message.pop, message.pop. And now we're going to message.append. You can see this says program is extremely hard. We need to change this to super easy. So the first thing we need to add is super. And the second thing we need to add is easy. And if we print the message out, you can see we now say programming is super easy. If you want to go step by step to see what we were able to do, you could, if I copy this print message, and I paste it after every single step, you can step by step see what we were doing within each of these. So programming is extremely hard, we popped the end, so now it's up to extremely, popped the end again, now it's is, added in super, added in easy. And I'm hoping you were able to get that. Again, if not, you can make up your own problems if you wanted to try to understand these pops and appends. I don't use pop as much. I use append quite a bit, and you probably will as well. So that is one thing just to note that it does go to the end of the list when you're doing that. Okay, slowly getting to the end of lists. Next thing we're going to do is looking at how do we change the values within a list. So if I have my list is equal to 0, 1, 2, 3, and 4, maybe I want to change the first value to be 4 instead. So how do I do that? Well, it's going to be the same thing as we were doing before with the indexing. So I have my list. Now, again, I want to change the first value. The first value is index 0. So pass those square brackets with a 0. Now I want to say that value at 0 is equal to the value of 4 now. So if I start printing the list, my list, and I print it again after we did this, you can see our original list was 0, 1, 2, 3, 4. Now it's 4, 1, 2, 3, 4. I can keep doing that. I can, if I copy this, bring it down, maybe I want to change the third value or the second index to be equal to 5. I can do that. And like before when we were indexing, you can also say I want the very last value, the -1 value. Maybe I want that to be 0 now. So you can see different ways of reassigning it based on the index. I'm hoping I'm really hitting home of indexing is super important. You need to understand how to do indexing. It starts at 0, ends at list -1. I keep saying this because it's going to come up a lot, and it's going to be probably the source of a lot of your pains, especially to start off with. So just know that and just really keep hitting this. And we're going to go, again, another exercise here because we really need to understand this and how to use it. So what we have here is we have a message that says coding is actually really hard. Okay, so copy that down here. This is our original message. I want you to be able to change this to say programming is not actually hard. So go ahead, use re-indexing, so reassign these values in order to make the list say what you want it to. And again, you can use print statements after every single operation you do just to make sure that you're correctly doing it. So go ahead, take a second, and then we'll come back and get started. Okay. So the first thing we need to do, I'm just going to go left to right, is we need to change coding to programming. So I'm going to say message at 0. Again, first value, 0, is going to now be equal to programming. Just to show you, I'm going to print message out every single step we do it, just so you can see one by one what we are actually working on here. Okay. So now we got programming is actually really hard. Next thing I need to change is I need to swap actually to not. Actually is in the 0, 1, 2, the second index. So if I copy this right here, bring it down here, now I'm going to change the second index to be not. I'm going to print that out of the screen. Now I have programming is not really hard. And I'm going to change the really to be actually now. Just to show you that I can, I am going to say message at -2, that's 2 from the end, is going to be changed to actually. Now our line says programming is not actually hard, which is what we wanted to be at the end. I'm hoping you were able to get that. Again, if you didn't, go ahead, take some time, try to figure out what I did here. Make up your own problem if you want to, and just really try to see if you can change these. But that's enough on lists for now. We're going to be looking at our last thing for this video, and those are dictionaries. So dictionaries are pretty cool. Lists store values within there. Dictionaries do as well, but instead of just randomly storing those values in the list, dictionaries actually store it with a key that you're able to reference and get the value from it. So in order to define a dictionary, we're going to be using these squiggly brackets. So I'm going to say my dictionary, so my dict, is equal to, and then squiggly brackets. Now, dictionaries, like I said, store things in a key value pair. So as you can see within here, we have a key, which is on the left-hand side. So the name, followed by a colon, followed by whatever the actual value is. So in order to do this in here, I'm going to have name, which is going to be a string. It's going to be followed by a colon, and the name is going to be equal to Tom. Now, your keys need to be strings. Just also something to be aware of. You need to make your keys strings. And so this will give us a dictionary that has only one value in it, and that value is name, which is equal to Tom. And so if I want to add more values to that, I can say, okay, I'm going to also have Tom's age be equal to 27. Now again, I have a string as a key, but I have an integer as the actual value. You can also do that as well. And maybe I have another one called coding expert. And right now, coding expert colon is going to be false. Maybe he's not a coding expert yet, but this is a bool value, so you can store multiple different types of values within here. If I go ahead and print that dictionary, you can see all of those are reported to the screen. Another way, and I don't use this one as much, but you definitely can use it. You can define my dictionary. Still, sorry, not with squiggly brackets, but with the keyword dict, D-I-C-T. And then that's going to be followed by parentheses. So now what this is going to do is you're going to go one by one. So I'm going to say the name is equal to Tom. And then I'm going to say the age is equal to 27. And then the last one is going to be coding expert is going to be equal to false. Now if I print this to the screen, I do have something wrong here. Let me see. Let me look at what I am missing here. Okay, let me take a second. I'm going to pause the video to figure out what I'm missing. Okay, unpausing, I realized what I did here. Okay, so when you're looking at a dictionary and defining it with the keyword, it's going to be looking for all of your keys, and I didn't highlight this before. It's going to be looking out for all of your keys to be not strings. So if I say coding expert, and I'm just going to replace the space with an underscore. Now it's very important that you don't have a space here because the space would be two variables instead of just one. So I'm defining these as variables. And so instead of defining it as a string on the left, I need to define it as a variable name. And so now if I run this, you can see our dictionary has been corrected. So something to be careful. I didn't highlight this, but again, the keys need to be variable names, and we're going to be assigning those with an equal sign, not a colon like we have up top. So my bad on that one, but as you can see, we're all set. And those are just two ways of defining a dictionary. When I define a dictionary, I normally use the top one. I don't really use the bottom one at all, but there's other ways of doing it. Okay, so cool, we can store values in it, but what really comes out of it is how do we get those values from the dictionary? So let's look at the one we had before, and I'm just going to copy this first line here. We have this dictionary that we defined up top with the name, the age, and the coding expert. But what I really want to know is, okay, I have this dictionary, and I want to know what the person's name is. So if I print my dict name with the square bracket. So like a list, when we were using the square bracket to grab an index, instead of grabbing an index, we're going to be grabbing what the key is. Again, the key is the left-hand side of the colon. So if I print this out to the screen, you can see, hey, that person's name is Tom. Or if I wanted to, I could say, actually, let me come down here. We're going to define a new variable called age. And age is going to be equal to my dictionary at the age. Make sure you're using a string when you're referencing the key, but the age is going to be saved as a new variable. Now if I just print age out to the screen, you can see we stored it as a variable, printed that variable out to the screen. And again, I could do the last one, my dictionary at coding expert. Then you can see it prints out false. So different ways of grabbing those values. Okay, like we did with the list before, I want you to go ahead and print out to the screen this message. So programming is not actually that hard, but I want you to do it by using this dictionary. So if you copy this dictionary down, you have this dictionary, it has a whole bunch of words in it. If it makes it easier, you can actually bring these down on different lines just by entering a space here after the comma. And this will still execute as one line, so one dictionary. But you can be able to see the keys are on the left, the values are on the right, a little bit easier. And so now you can actually just work through this, try to print out the phrase, programming is not actually that hard. Take a second, pause the video, take 5 minutes, come back. Okay, let's work through this. First word is programming. So we have our dictionary called message. Message, looking for the key, which is word 3. Okay. I'm just going to go ahead and print that to the screen. You can see, boom, we grabbed programming. And now it's just working through this list one by one, grabbing the ones that we need. So I'm going to copy this. Is word 1. Not is word 6. Actually is word 2. Program is not actually that is word 5. And hard is word 4. Let me see if I did this right. Programming is not actually that hard. Perfect. Okay, so different ways of referencing the keys and grabbing those values that you want. Again, if you didn't get this, go ahead, just retry it, maybe make up your own words, but just understand how to reference values from a dictionary. Okay, just like we did for the list, we're also able to add values to the dictionary and remove values. So adding values is fairly simple. I'm going to, again, copy this dictionary. I don't want to really type it all out again. It's the same dictionary that we've been using, but maybe now we want to add a degree for Tom. So I'm going to say my dictionary, and now I'm going to pass square brackets. And like we did before where we're adding a new index or reassigning a new index, we're going to be adding a new key. So now I'm going to say degree. That's going to be my new key. So my dictionary at degree is going to be equal to computer science. Now if I print the dictionary, you can see we have added a new key value pair called degree with the value of computer science. So ways of adding values. You can also remove values. And this is going to be very similar to the list. So if I have that same dictionary, I'm going to copy this down. Maybe I want to remove that degree that I just added. So now I have my dictionary dot pop. Now, like before, when you're using a list, when we popped the index, it popped at whatever value was at the second index or whatever we may be doing. Instead of using index, we're going to be using the key. So now I want to pop degree. This is going to remove degree from the dictionary. If I have the original. Okay, so you can see our original. Now we popped a degree from it, and degree is removed completely from the dictionary. Great. Last thing before our final exercise is, just like lists, we can also change the values that are stored in dictionaries. So if we're going and grabbing this dictionary again, maybe after the end of this person, Tom, has become a coding expert. So now I can say my dictionary at coding expert. Now if you look, coding expert is already in this dictionary. So when I say coding expert is equal to true, it's just going to reassign that value. And when I print out the dictionary before and the dictionary after, you can see that originally coding expert was set to false right here. But now coding expert has been switched to true. So this guy has become a coding expert after this tutorial. So ways you can change it. Very last exercise, kind of like we did before. I want you to change this dictionary, the one we've been using this entire time, but I want you to change it to add, or to change it to be what your values are, what your name is, what your age is, your coding level, your degree. Again, if you want to make this a little more readable, you can put a blank line after each one of these key value pairs. So now all your keys are on the left and all of your values are on the right. But go ahead, work through this, try to switch it to what your values actually are. Okay, I'm going to use my own values for this. So my dictionary at name, and my name is Adam. Make that capital. Okay, again, I've hit on this before, but I go back and forth between using single quotations or multiple quotations. Does not matter. Python treats them the same, even if you're using it as a key. Okay, so changed my name. I actually am 27, so I don't need to change that. I'm going to change my dict at coding expert. This is one thing that can't happen though. If you see here, I started with a single quotation mark and ended with a double. That will not work. You need to end it the same. So just be careful of that. Okay, I'm going to say that I am a coding expert, even though I don't know if I really am. And now I'm going to change my degree to be AI/ML engineer. Okay, now if I print out the dictionary, I have my name, I have my age, I have my coding expertise, and I have my new degree. Cool. Hopefully you were able to get that. If not, try to change it up. Try to add more values, maybe. Different ways of using the dictionaries and see what you can do. But for now, that's where we're going to stop. Again, these are the very basics of how to start using variables within Python. They're the building blocks for what we're going to be doing next, and that's getting into the more complex things and really unlocking the power of Python. This may have been a lot. I know it's a lot to cover in an hour, but really try to go through this, especially lists and dictionaries. Try to really get a little bit of an understanding. If not, the next video, the next exercise is really going to hammer this. So you're going to have plenty of time to learn this and really get a feel for how to use these. But for now, thanks for joining, and stay tuned for that next video, and keep up with this bootcamp.